Hello, my name is Sudrisya Pokhrel. Today we are going to study another topic, electric circuit response. इलेक्ट्रिक सर्किट रेस्पोन्सको बारेमा बुझ्न पहिले हामी स्टेडी स्टेट एनालाइसिस अफ आरएल सर्किट बुझौँ। आरएल सर्किट भन्ने बित्तिकै एउटा आर एउटा एल त अभियसली हुन्छ नै हैन। अनि इन्डक्टरले सडन चेन्ज इन करेन्टलाई अलाउ गर्दैन है। सो भोल्टेज करेन्ट को रिलेसन अथवा सडन चेन्ज इन करेन्टलाई अलाउ गर्दैन भने करेन्ट ल्याग बिहाइन्ड भोल्टेज। यस, अनि यसको के हुन्छ इम्पिडेन्स भनौँ भने एक्सएल स्क्वायर हुन्छ आरएल। जब अल्टरनेटिङ करेन्ट पास गरिन्छ, that inductor doesn't allow sudden change in current. The current would be constant. So E equals to L di by dt. That is, sudden change in current is 0. EMF would be 0. That means it acts as short circuit. Voltage 0 हुन्छ। Capacitance. Properties of a capacitor is it doesn't allow sudden change in voltage. So impedance Z equals to R square plus XC impedance Z equal to R square plus XC root under similar like this. But what is XC and XL? Yeah, I've said that it doesn't allow sudden change in voltage. That means current equal to C dV by dt. We know that. So the change in voltage is 0, current is 0. That means it acts as open circuit. Okay, now what is XC and XL? XC is 1 by omega C and XL is omega L, where omega is 2 by F. F is a frequency. Yeah, so capacitance doesn't allow DC. How? Constant voltage, that means frequency is 0. That is XC equals to 1 by 2 pi FC. Frequency is 0. That means 1 by 0. XC equals to infinite. That means it doesn't allow DC voltage because its capacitance is high. Now RLC circuit consists of resistance, yeah, wait, resistance, capacitance, and inductance. Yeah, and capacitance, I mean capacitor, stored energy in the form of charge, where inductor, sorry, in the form of voltage, and inductor in the form of charge. So when the alternating current is passed through this circuit, the inductor and the capacitor store and release energy, resulting in a complex waveform. The magnitude of the impedance of a RLC circuit would be Z equals to R square plus XL minus XC whole square root under. I mean 1 by 2. Okay, XL minus XC, sorry, whole square. Okay, R square plus XL minus XC को whole square को whole 1 by 2. Okay, now if I say case number 1, XL is greater than XC, that means it is certain value, and if it is their square means that is a positive value, and plus R square, let us suppose that would be Z1. Okay, now if XC greater than XL, that means it is certain negative value, and its square is positive value. R square plus positive value would be Z2. Yeah, so Z1 and Z2 is always greater than ZR. How? I mean this ZR is if XC equals to XL, obviously the 2 will be cancelled out and only remain is R. Z equals to R, so ZR. So ZR would be always minimum, I mean minimum, not greater than Z1 or Z2. That is, XC equals to X2, the impedance will be minimum. And if a ZR, then current and voltage have same phase angle. That means phase angle is 0. Okay. Yeah. So how these conditions happen? That means at resonance, XC would be equals to XL, and at this condition Z would be minimum, and current and a voltage as phase angle 0. Always remember this. Now transient analysis of RL circuit. Transient analysis of RL circuit. Consider a circuit has a voltage source, inductor, this is 1, this is 2, and at first this circuit is closed. And it would be moved to 2 at t equals to 0. Okay, now case 1, when t is smaller than 0, that is I0 would be b by r. Yeah, because the voltage, the current would be this, moving toward this and ends here. So current would be v by r in t smaller than 0. When t is equal to 0, this key will move towards point node 2. So the circuit would be to this resistance and inductance, and this will move this. Wait. Inductance, and this is resistance. This is resistance, this is inductance, and at t equals to 0, this key will move from point 1 to point 2, and the circuit would be this. And before t is smaller than 0, the inductor would get charged, that is I will flow from here, so it will get charged or store energy. So the direction of current when it's charged by a source, when it get discharged through the load, will be same. So minus, this is plus. And now let's apply KVL in this circuit. VR plus VL, VR plus VL. Now let's solve it. VR means I mean T, yeah, times of R plus VL is L di by dt. Okay, and this is also IT. Now let us forget this IT and only write I. Okay, so I R plus di by dt times of L equals 0. Okay, now let's move this in this side, that is di by dt is equals to minus IR, yeah, and this L would be divided by in divide form. Okay, now let's move this T in this side and I on this side, that is di by I is equals to di by I is equals to minus R by L times of dt. Now integrate on both sides. Integrating on both sides, we get ln I is equals to minus wait minus R by L and the time t integrating on and plus we will suppose the constant ln k. Okay, this is the constant, so we can suppose is in a lm form. It would be k, yeah, it would be k, we understand, but if we can manipulate it and we can write it in ln form. Okay, now let's wait. In the ln form, that is ln k. Okay, now let's move this k in this side. We get ln I by k, because ln I minus ln k would be ln I by k and minus R by L upon t. Now we apply exponential on both sides. We get I upon k is equals to minus minus R by L times of t. Okay, so I would be minus R by L sorry wait okay, now applying exponential on both sides, we get I by k is equals to exponential minus R by L into t. I forgot this one. Okay, so I is equals to what? K times of e minus R by L times of t, and we can manipulate this into t by L by k, and this L by k is nothing but time constant. That is, I is equals to k times of e to the power minus t by tau. Okay, this is the equations of the inductor, I mean transient analysis of an inductor, and this is I t. Okay, now what is k? We can find it by taking a condition at t equals to 0. The current would be V by R in the inductor. So I mean in the circuit, the current would be V by R. So now applying in this, so t equal to 0, the e to the power minus 0 is nothing but 1, and I 0, I mean this is the IT. I have said before, IT is equals to k times of 1, and this IT we have applied 0, so I0 is nothing but V by R. So V by R is k. Now again we substitute this value to this equation, we get IT is equals to k is V by R, that is I naught e to the power minus t by tau, and tau is nothing but L by R. This is a steady transient analysis of an inductor and resistor circuit, RC RL circuit. Okay, we have understood this. Now let's see how the graph will work. How the graph will look. At t smaller than 0, there is a sudden current, that is I naught, and after that t equal to 0, the current will start decaying, and it decay like this because it has a minus exponential term. Now if this I naught, I mean V by R small, that means R is R is large, then this value would be small. That means if we decrease R, then the graph will look like this. Wait, I will make you understand. Okay, and the graph will look like this. And what happens if we increase L? Tau is equals to L by R. Wait, tau is equals to L by R. If we increase L, the time constant will be increased. That means it will take larger time to decay. So the graph will look like this. Wait, this. So when R is increased, the graph will look like this, and if L is increased, the graph will look like this. Now, did you get the concept? Okay. Okay. Now unit response in RL circuit. Plus minus, this is a voltage source, this is a resistor. At the time t equal to 0, the switch will be closed, and this is wait, inductor. Okay, at time t equals to 0, switch would be closed. Okay, this is a resistance, this is a inductance. I've got this. Now total current would be I plus I S S. And what is I? I is a transient current, and SS would be steady state current. And ISS is nothing but V by R. At steady state, the whole current will flow. But when you suddenly apply, when you suddenly close the switch, the inductor will resist the sudden change in current. So transient resistance would be different, and at a steady state, that means at t equals to infinite, the current would be V by R in the circuit. And we have known that transient value would be k times of e to the power minus t by tau. We have already derived it, and tau is nothing but L by R. Okay, now let us apply here the KVL. KVL says that del V equals to 0, that is sum of voltage drop across each element would be 0 in a closed loop. Yeah, so Bs minus IR minus L di by dt would be 0. Yeah, V, that is moving upward, positive sign, and the current will move from higher potential to lower potential, that would be minus, and here also minus. So, and Now this circuit would give us I K wait I mean I T would be K E minus T by tau plus V by R. Yeah, so this would give this, and ISS is nothing but V by R, that is a total current. Now what is I naught? Now IT is K E minus T by tau plus V by R. At T equals to 0, K E minus 0 plus V by R, that is K plus V by R equals to I naught, and I naught is nothing but K plus P by R. Sorry, K plus K plus V by R. And what is K? I naught minus V by R. Yeah, K is I naught minus V by R. So if we apply this equation, ISS plus I transient, we will get K is what? We have derived it, and IS is what? We have derived it, that is V by R plus I naught minus V by R e to the power minus T by tau. This is when inductor initially energy is 0, I naught is 0. So if value of T increases, V by R minus T by tau tries to decrease, and IT approaches to V by R. Jump.